Within every deck list, there will always be a gradient of which starting active Pokemon you prefer, going from the one that you're always happy to start with, going to the one that you really don't want to have to start with. Tapu Lele-GX! Tapu Lele-GX! Well, there's some math involved, so let's dig into it. So let's start with a few definitions first. For Big E being every possible starting hand for a given deck list, E being every starting hand that does not trigger an automatic mulligan, we have Big B, every starting hand that includes at least one basic Pokemon, B, the amount of basic Pokemon that includes included in the given deck list, D, the amount of cards in the deck at the given event. Okay, so let's take this deck list here that was driven by Benjamin Pham to the top 16 position, well, among the top 16 position at the London November 2017. It's a Zoroark GX Scarlet Spot list, and it's a quite fun one. And so let's start with a few disclaimers. Oh, by the way, Benjamin Pham's list is very similar to the list that won the tournament. So the first disclaimer is that I have no on-hand personal experience with this deck list. So anything that I say regarding how to play it is pure speculation. The preferred starting active Pokemon may change based on the matchup. Again, I haven't played the deck, so I wouldn't know how to apply this specific deck list, but that's something that is true for a lot of decks. And lastly, I'm an idiot. I mistook Mr. Mime for Latios. My bad. But the math was already done, so I'm gonna pretend that it's a Latios. My bad. So, if we have Benjamin's fam modified list here, what would be our preferred starting active Pokemon? Well, I suppose that the preferred active would of course be Tapu Koko. Wait a second. Why is my Tapu Koko flipped over? The second preferred would probably be Wimpod. Both of these have, on the first turn of the game, free retreat. Tapu Koko having it all the time, but Tapu Koko has more HP and Tapu Koko can attack, making him the preferred choice. Now the third option would be Latios, which isn't actually here, but yeah. Let's go back to pretending now. So Latios would be the third pick because it still has a rich cost of 1 and can still attack and has a very good attack on the first turn of the game. It's a great early game attack, doing 30 damage, might even take you kills if you're playing against someone who has a psychic weak Pokemon. The most notable basic right now that would get one shot by this stack would be um, Rockruff. Although not a lot of people play Rockruff, but still, it was still a card played among the day twos at London. And the fourth preferred option would be Zorua, uh, because it has a rich cost of 1. It's not as the other options. So, what's your chance getting your Tapu Koko, your Wimpod, your Latios, and your Zorua? Well, let's start with Tapu Koko. So, if we want to have Tapu Koko, we basically need one Tapu Koko in hand and any other six card basically. Um, but here we cannot just ask what's the chance of getting Tapu Koko in your first hand because in the first card you draw, because if it's not there, you would need to add the chance of getting the second card, and if it's not there, the third card, the fourth card. It's a very messy tree of mathematics that is not fun. It's messy. It takes a lot of place, and we cannot use the hypergeometric equation that we used last week either. The hypergeometric only gives you the good result if any draw of card counts. But because of the rule of Pokemon, if you have no basic in hand, that hand, those drawn cards, do not count. You mulligan. Well, that rule prevents us from using the hypergeometric formula here. So what we're going to do instead is that we're going to flip it over. And instead we're going to look for a chance of not getting Tapu Koko. And that should look familiar to those who've seen the other videos on my channel, because that is basically the Talonflame equation. And of course, so here we have the Talonflame equation. We're going to have to modify it a little bit, and let's do just that. Okay, so the first thing we're going to modify is, again, Froakie here is standing in for all the basics we don't want, meaning all the basics that are not Tapu Koko. So on the first draw, which is going to be defined as our basic, again, it doesn't have to be the first card you draw, but because you multiply all of those events together, the mathematics will be exactly the same. So we're defining it as the first one. So the chance of getting that first basic will be the amount of basics you have minus your first priority Pokemon, in this case Tapu Koko, divided by your whole total of basics, multiplied by the amount of cards left in the deck minus your priority 1 Pokemon times the amount of cards left in the deck at the third event minus the Tapu Koko divided by 58, and on and on and on until you have your 7 cards. Now, that's for your first preferred Pokemon. Now, what if we're talking about Wimpod now? What about our second preference Pokemon? How would you calculate that? Well, you would do almost the same thing, except now rather than doing basic minus your preferred choice, you would say minus all of your choice that fit the second choice and below. So you would count your Wimpod and your Tapu Koko. Then you would divide it up basic. Then you would do the amount of cards left in the deck minus all your preferred choice of 2 and lower, divided by the amount of cards left in the deck, and on until you have 7 cards. And then you would take that and you would subtract to this whole result the probability of getting Tapu Koko, which would give you the probability of getting Wimpod. Because remember, if you have a Wimpod in hand, but you have a Tapu Koko in hand, then you're playing Tapu Koko as your active, not Wimpod, because we have already defined Tapu Koko as being your preferred starting active Pokemon. If we were to add a third Pokemon, like our third preferred option, we cannot just do our preferred of preferential 3 and lower instead of preferential of 2 and lower, and then just minus Tapu Koko. Now, if we want to generalize this formula, we need to say that the probability of getting your preferred n will be equal to 1 minus the big multiplication of b minus your preferred n and lower divided by b times 59 times 59 minus all your preference of n and lower divided by 59 times 58 minus your preference of n and lower divided by 58, and on and on until you have your 7 cards, minus your preference of the probability of getting a preference of n minus 1, so just the one below that, minus the probability of getting the preference of n minus 2, minus the probability of getting your preference minus 3 until you get your probability of 1. So that's the formula we need to be using. So let's put it as an example. So here's the formula again. We're using the same deck list, of course, which has 13 basic Pokemon. So let's go with Tapu Koko first. So we plug in the numbers, we simplify all the above division and below division, which will cancel each other out, which will give us with a nice 1 minus 12 divided by 13, 53 divided by 59, which gives us this nice number of 0.170795306, which gives you 17.8%. That's for Tapu Koko. Now for Wimpod. Plug in the numbers again. Now, this time we will have, it's not as easy to simplify. You have 1 minus 9 times 53 times 51 times 25 divided by 59 times 29 times 57 times 14 minus 0.170695306, which will give you the number of 0.38377859.2, which roughly comes down to 38.38%. And now, what about your chance of getting your Latios? Yeah, sorry about that, guys. Plug in the numbers, and once we simplify it, we get it's 1 minus 4 times 59 times 51 times 5 times 7 divided by 59 times 29 times 57 times 11. All of that minus 0.55 44 73 99 89 8, which gives you a result of 0.082784623, or roughly a 9.78% chance. Now onto Zora. If we plug in the numbers, remember now at this point we have to subtract the chance of getting all of the above Pokemon on the image and the below in terms of preference, which will let us, once we simplify, get it down to 1 minus 25 times 7 times 8 times 47 times 23 divided by 13 times 59 times 50 times 13 times 59 times 29 times 57 times 11, all of that minus 0.64 73 58 52 1, for an answer of 0.24412571 or roughly 24.41%. And we could go on until we do the whole list of all the basic Pokemon. We could do it for Mewtwo, and then we could do it for Tapu Lele. But after the first few options, it loses a little bit of meaning, and it's a lot of calculation to get all to the bottom of your list. And let's be honest, we more often than not fear getting Tapu Lele than we care about getting either Mewtwo, Zora, or Latios as your active. So let's do the math in reverse, or more specifically, let's answer the question in reverse. So the chance of having a bad active Pokemon, or the unchance. Now, in every case, every serious deck out there, the worst active possible is Tapu Lele-GX. So now we need a hand that starts with Tapu Lele-GX. So your chance of getting Tapu Lele-GX will be U standing for undesirable divided by the amount of basic in the deck. So the amount of Tapu Lele divided by the amount of basics. Then you would want the amount of cards left in the deck for the second event minus the amount of basics left in the deck minus the amount of undesirable -1, because we already have 1 in hand, divided by the amount of card left in the deck. Same thing for the third event, fourth event, fifth event, until you have your 6 cards. Now we can simplify it to this formula here, and that will give you your chance of getting Tapu Lele as your active. Now, what if we want our second worst? Let's get, in this case, Mewtwo. Remember here, I'm saying it's Mewtwo because I thought that Mr. Mime was a Latias. Uh, Now, in this case, you want to add the undesirables, the second undesirable to the first undesirable, divided by b, and then it's mostly the same thing. You just add them together again, and then just like with when you're looking for your preferred starting active Pokemon for your least desirable, your undesirables, you will calculate, you will have to subtract at the end the probability of starting with your worst undesirable. Because if you have to choose between Mewtwo and Tapu Lele-GX, that choice is easy. You're gonna start Mewtwo. Let's go back to Benjamin Fan's list. What's the chance of getting Tapu Lele-GX? We plug in the numbers, we simplify to get 25 times 7 times 6 times 47 times 23 divided by 13 times 59 times 29 times 57 times 11, which gets us 0.081 38 68 21, which roughly gives us 8.14%. And when it comes to Mewtwo, we plug in numbers and we simplify and get 4 times 51 times 7 times 2 times 47 times 23 divided by 13 times 59 times 29 times 57 times 11, all that minus 0.081 38 68 21, which gives us 0.13998533.4, which roughly gives us 14%. Okay, guys, so that's it for today. Next week, we will be talking finally about turn 1 Tapu Lele plays for those turn 1 supporters. But what about after that? What about the next week after next week? Well, you decide. So, one of the options we have is the Victory Star Victini, which sounds simple, and honestly, it's not very complicated, but it does have some nice intricacy to it. Or we have Guzzlord and its Eat Sloppily attack. Or again, you can just make any suggestion you want. So have fun and comment. See you next time.